All right, we are back. Check it out. Example 3 states, in an amusement park ride, a car travels according to the equation D equals 1,250 times T, where T is the time in minutes and D is the distance in feet the car travels. Below is a chart of the times that the three people have been in the cars. Graph the relationship between time and distance, and then how far has each person traveled. So this is the question we need to answer. How far has each person traveled? That's referring to the distance, and then we need to graph the data. So we need to do two separate things. So for this example, we have the riders and then we have the time. The time is the same thing as our x, and that it would be the independent variable, and the distance is our y, or the dependent variable, which means however far you go depends on how much time you are traveling in that particular direction. So let's go ahead and create our table. So here we go. Our table right here is T, and then we are going to need to calculate the distance, which is going to be found by this equation, 1,250 T. That's how we're going to find the distance, and then we are going to calculate, make an ordered pair, which is going to be TD. Okay, so remember the T, that is our X, and the D is our Y, so this ordered pair would be X, Y, that would be our T and our D. So let's go ahead and do this. So our first, Ryan has been in this car for 1 minute, so that means our time is going to be 1. We're going to substitute that into this equation, which means the distance is just simply 1,250. So the ordered pair, the solution on this line would be 1,250, and that's the amount of distance that Ryan went. So we can say Ryan's distance is 1,250. Okay, let's go ahead and calculate Greg's distance. Greg's distance was 2. He was in the car for 2 minutes, so the distance he went would be 1,250 times 2, which actually ends up being 2,500. So the point that we're going to have to graph is going to be 2 for the T value and 2,500 for the D value. And then there was one more. There was Colette, and Colette was in the car for 3 minutes. So we're going to stick 3 into our equation, and we end up with 3,750 when we multiply those, which gives us the ordered pair of 3,750 right there. Oh, I forgot to say. So the distance that Greg went, so Greg's distance was, what was Greg's distance? 2,500. And, oh, I think it's in, what is it? What are the units? Distance in feet. So 1,250 feet, 2,500 feet. And lastly, Colette's distance would be 3,750 feet. So that is the distance that she traveled. Okay, so let's go ahead and graph these points. All right, we know that our x-axis is actually, this is the same thing as t. for time. So over here on our x-axis, this is going to be our t. And then our y-axis is actually the same thing as distance. So the y-axis is going to be our distance. Okay, so our time is in minutes and our distance is in feet. And notice I have one of these little squiggly line things here, which means on the time we're going in increments of 1. That's pretty simple. But there's a lot of distance going on, so we kind of scrunched up the graph and kind of jumped to 1250 and then 2500 and 3750 and 5000. So that's kind of the increments that we're going on the y-axis, which represents the distance. So let's go ahead and graph these ordered pairs, these points right here. So for 1, when time is 1, the distance is 1250, which would be right here. 1. There you go. For 2, it's 2500, so when it's 2 minutes, the distance you travel is 2,500 feet. And then for 3 minutes, it's 3,750 feet. So we have 3 points. We can go ahead and connect those dots, and we will get our linear relationship right there. There you go. That is it. And I hope you all did the table and the graph and you stated the distances. I hope you all did it correctly. If you did, yoka denki mashita. You did a great job, and we will see you next time. Goodbye.